Good afternoon, everybody. It's the top of the hour, so I'm going to go ahead and kick off today's webinar. Just a couple of quick housekeeping things before we get started. Today's webinar is being recorded, and we will share it after the session is over. And if you have any questions, I am joined today by my co-host and VP of Engineering, Ravi Balapuri. He'll be helping me answer any questions that you guys might have, so please go ahead and enter them into the Q&A. He'll either try to answer them live, or if we have a few minutes left at the end of the call, we'll go ahead and try and tackle them then. With that said, let's go ahead and dive right in. So the agenda for today, we'll go through a quick introduction of API Shark. We'll talk about why you would want to blueprint your APIs. And this is on discussions that we've had with over 100 different enterprises. We'll talk about a quick demo architecture, and then we'll get hands-on and jump into the actual installation of the API Shark tool. We'll walk through a API recording, and then finally, we'll come back and provide you with some options in case you need some support. So with that being said, let's go ahead and introduce API Shark. So API Shark is CloudVector's free community edition tool. It's currently supported for all Kubernetes deployments. So this is regardless of cloud provider. So for example, you could run it on Google, Azure, AWS, etc. And the free community edition version of the tool actually allows you to do deep API inspection and observability of all your APIs. And you'll see that as we walk through the demonstration here in just a few minutes. So why would you want to blueprint your APIs? So here are the top 5 reasons that we've come across in talking to our customers. So as folks are doing more and more of the migrations to microservices and digital transformation, it's leading to an API proliferation, which means more and more APIs are now being exposed not only to customers, but to third-party providers, etc. We're also being told that the process of blueprinting or cataloging your APIs today is very manual. It's often tedious. Developers have to continually update their documentation, and they don't have an automated manner in which they can do this. And what leads to that is the rapid development and deployment of applications. So gone are the days where you have a deployment once a month or once a quarter. Lots of organizations and enterprises are now releasing several times a day. And as part of those releases, there's updates to the API specification, and it becomes very tedious and laborious to keep the specs up to date. Aside from some of the development issues, there's also a huge benefit for API specifications when it comes to onboarding and maintaining your API gateways. So a lot of gateways have the capability to create endpoints and proxies, but they require you to feed them an API specification in order to do that. So if you don't have an accurate blueprint of what your API specifications look like, it becomes, again, a very tedious task for you to go through and configure each one of those. And on top of that, as changes to your APIs occur, changes to the gateway need to be made in real time. And finally, we're finding a lot of enterprises that have vulnerability or risk assessment tools. So for example, some type of API vulnerability assessment scanner. But these tools are not, they're quite useless unless you can provide them with the API spec that you can scan against. So it's super important that you have a accurate and up-to-date blueprint of your APIs. Okay, so this is an architecture of the demo that we're going to be doing today. So it's a very simple setup. It's a single node Kubernetes cluster. We've got 2 pods running. I've already gone ahead and deployed a demo banking application, which we'll use. And today we'll deploy the API Shark controller. Once the controller is installed, we'll download and go ahead and install the microsensor as a sidecar. And what you'll notice here is that we don't have to make any changes or shim the code. This is simply a sidecar that gets deployed alongside the demo banking application and starts gathering all the information. Okay, so with that being said, I'm going to jump into my console and show you the Kubernetes cluster. So you can see here that we have a blank cluster, and the only thing that's running on there currently is the demo application that we referenced. So in order to install API Shark, you'll first need to visit the download site. You can fill in some simple information here. Once you hit submit, you'll receive an email, which will present you with a download link. Once you get the download link, you simply need to copy that link and then download it onto a system that has access to your Kubernetes cluster. So for the sake of time, I've gone ahead and actually downloaded that setup script, which you can see here as setup.sh. So I'm simply going to go ahead and execute that script. and pass it the install parameter. So when we do that, it asks us a couple of questions. For example, here it's asking for the namespace, and then it'll go ahead and ask us if we're running in a Google Kubernetes environment. We're not, so I'm going to hit no. And the reason that that question is asked is because Google handles persistent volume claims a little bit different than some of the other providers. So now that we've deployed it, let's take a look and see what our stack looks like. So if we do a kubectl get pods, and take a look at all the namespaces, we can see that the demo app is running, and now we can see that all the CloudVector API Shark services are running as well. So the next thing we want to do is get the service port. So if we do a kubectl get service, we can see here that the CloudVector web node is exposed on this particular port here, which is 31522. So we're not going to get into the actual Kubernetes administration on this webinar. So the assumption here is you have some basic understanding of how to expose and access ports. So let's go ahead and grab this port and switch over to a browser. And then we can hit that IP on this particular port. And the first time that you access the CloudVector API Shark, you'll be prompted to create an account. So you can see here, we just provide it with our first and last name, give it an email address, and then set up a password. Accept the terms and conditions, and go ahead and create that account. So for the first time, it'll walk you through a welcome screen. It'll identify the steps that you need to take. So you can see here, the first thing we're going to do is create a microsensor, identify an application that we wish to inspect, and then we're going to go ahead and run and deploy the microsensor installation script. So we'll walk through here, and then now we can get started. So we can see that the console is up and running, and we are ready to go ahead and install a microsensor. So to do this, it's very straightforward. You head over to System Config and select Create Microsensor. Now you'll notice we have a variety of microsensor types. In the Community Edition, the only version that's available is the Network Packet Sniffer. So we're going to go ahead and select that, hit Save, and then we're prompted for a couple of pieces of information here. So we just need to give it a name, a description, and in this case, it's Community Edition, so we only have the Kubernetes cluster, but you do have the option of choosing between a sidecar or a daemon set deployment. For this example, we're going to just install the sidecar and just sniff the services that are in the demo banking application itself. So once we hit save, it's going to go ahead and generate a deployment script for us, which we can see here. So we're going to copy this script, and then if we click the installation instructions, we'll give you a 7-step guide on how to install this. It's actually very straightforward. So the first step we did, which was to copy the deployment script, log into a machine that has access to the cluster, and then download the script itself. So we can see here, we just need to perform a wget. So if we head back to the machine, I have a microsensor directory here, so I'm just going to do a wget. We're going to call the file setup.sh and then pass it the link. So you can see here that it's going to go ahead and download that script for us. So if we go back and take a look at the next steps, it simply asks us to run that file. So we'll copy this command, we'll head back and execute that. It's going to prompt us if we're sure we want to install. We hit yes, and now it will download and install the script. So we're not going to pass any advanced parameters, but if you have specific configurations, you certainly can do that. So once we've done that, we can head back over, and now we need to create the actual config map for the sidecar. So in order to do that, we simply copy this command, and you'll notice here in the notes that we need to change our directory into this ABMS, the name of the microsensor that we gave earlier, and then the kubectl directory. So if we head back over and we do an ls, we can see that the ABMS demo folder was created, and inside there we have a kubectl. And then we can simply go ahead and paste the command. So that's gone ahead and created a config map for us, and then there's just one final step. we can see here that the final step is to patch the deployment itself. So let's copy this command. And then let's not forget that we do need to change the deployment name. So in our case, the application that we have deployed is called Bank Demo App. So now that we've done that, we can see that the application has been patched. So this time, if we do a kubectl get pods, we can now see that there are 2 pods running, and one of those is the sidecar instance. So now we can simply head back into the console. And actually, before we do that, let's get the port that the demo app is running on. So if we do a kubectl get services, we can see that our node port for the web application is running on port 31224. So let's go ahead and grab that, head back to our browser, and then we can access this application. So this is just a demo application that we've created for the purposes of highlighting our reporting capabilities. So I'm just going to go ahead and log into this account. There we go. Okay, so you can see here, this is just a fictitious bank that we've created, and it's built using APIs. So if we go ahead and just click around a little bit, we can take a look. And we're just really generating some traffic so we can see how this is captured within the API Shark tool. So spend $100 on lunch. Okay, so if we go back to the API Shark, and then we can go to events, and we can see that the events are coming in. So this is successful. We know that the sidecar has been deployed correctly and is monitoring our application. So there's a lot of other features within this community edition, but today we're going to concentrate on creating an API recording and generating the API specification. So in order to do that, you simply head over to recorders. You create a recorder. We will give it a name, give it a description. You can select the controller and the microsensor. In the community edition, you only have the one choice. And then we're going to go ahead and save and publish. So you can see here that this recording is now in a running status. So if we click this and head back over to the demo application and generate some additional traffic, we should see that appear in the tool in real time. So let's go ahead and take a look at the account. Let's maybe go in and do a transfer from one account to another. Do $1,000 transfer for, I don't know, Super Bowl tickets, maybe? Is that cheap? Is that too cheap? So we can do that. Take a look at some transaction histories. We can see here that the transaction for the Super Bowl tickets was made. So now if we head back over to our console, and we just refresh this page, we can see that the APIs are being recorded here in real time. And you can see that we did a transfer, we looked at some of the beneficiaries, and there were 5 parameters detected. So now that we know that the API recorder is occurring, we can go ahead and actually stop this recording. And when we stop this recording, this will go through and create and build the actual Open Swagger API specification file for us. So if we go back to the dashboard, I can quickly show you here some of the insights, response times, etc. And we'll cover a lot of these additional features in subsequent webinars, but you can see we do provide you with a lot of rich information in this tool. So now if we head back over to recording, we can see that that is completed. It had captured 3 APIs. So if we go ahead and click on this, what you'll notice now that it has aggregated and calculated the specification, we show you the API endpoint, the method, and the amount of parameters that were detected. So if we can see here on the transfer endpoint, we have this little arrow that lets us expand, and we dive deep into the actual API payload itself, right? So we're able to identify the parameter names, the parameter types, and where that parameter was actually extracted from. So in this case, it was from the body. Of course, for production use cases, you would let this run for a lot longer than a couple of minutes. You'd run through your test cases to make sure that you'd captured all your APIs. Once you'd captured those, you can go ahead and take a look at the specification by clicking on the two arrows there. And you can see here that we've got a nicely formatted OpenSwagger 2.0 API. And then you can also download and export this JSON file. As we mentioned earlier, this can be useful to onboard your API gateways or feed to your risk assessment tools, etc. And this can also serve as a golden blueprint if you run this recording within your test or dev environment where you know you've covered all your API use cases. So that concludes the demonstration portion, but I do want to quickly jump back and give you guys a couple of links. So you can see here on the screen, in order to download the API Shark tool, you can simply visit cloudvector.com/API Shark. We do have a community edition where you can sign up and get some additional help. A lot of the folks here at CloudVector will be monitoring the community forums. In fact, let me give you a quick look at those. We have some tutorials that have been posted. There's some videos, and we're continually adding to these. And you can certainly come back here and reference for any installation instructions. So with that being said, I am going to pause and see if there are any questions that we haven't answered here. So it looks like we have one question. Is this currently only supported on Kubernetes? Yeah, so currently the Community Edition is only supported on Kubernetes environment. We are not restricted, as I mentioned earlier, by cloud provider. So you could run this certainly on any of the major cloud providers, as well as local installation if you're using something like Minikube. Okay, it looks like I think that's all the questions. I'm going to open it up and see if Ravi Balapuri has any parting words, since there are no more questions in here. Ravi, can you hear me?
Yeah, Dinesh, thank you very much. So like Dinesh mentioned, the tool has a lot of other capabilities. One of the other areas that I tend to use this tool myself is to debug, my Kubernetes deployments. Whenever I see an issue with application services, I use the nice little API live view and look for what's happening on the wire. So when we started to build this tool, it was sort of, we had a question to ourselves like, hey, in a traditional world, we had Wireshark, which was for the network, calls to look at the network packets and stuff, but we couldn't find any tool that was equivalent for Kubernetes environment. So that's one of the motivations, along with the added benefit of developing, API catalogs and blueprints, which is a big gap for the current enterprises. So please try out the tool and let us know if you have any questions on our community forum. We are always listening. We would like to improve and make it much better so that it's useful for the entire community.
Yeah, Ravi, looks like we got another question here. So question is, can API Shark support virtual machines?
Yes, the community edition does not support. The community edition was primarily for Kubernetes environments, but we do have our enterprise edition, which is supported across multitude of infrastructures. So we support virtual machines. You can have a virtual switch that we can sniff. The second thing is we also provide an RPM or a Debian package that you can install on Linux machines and also in exe for Windows. We also support AWS Lambda, F5, Heroku, a bunch of other things which are primarily part of the enterprise edition.
Great, thank you, Ravi. And we've got another question here. So the tool shows the results of the network sniffing. Is there an option to input OpenAPI documentation, perhaps resolve what is found in network sniffing versus stated Swagger?
Yeah, that's a great question. That's exactly one of the features that we have as part of the enterprise edition. We call it as detecting out of spec APIs. So we have the capability to import a specification defined in OpenAPI Swagger format. Just to run through one of the use cases that we hear a lot, the development team has provided a Swagger specification and the test team is running through the entire application, functional and regression tests and everything. So they want to capture what are the gaps in what the development team has provided versus what the test team is, testing. So we have that capability, exact capability, and we generate a report which shows what are the APIs in the development spec that were not tested. So it's an area where the test team can improve the coverage. The second one is, what are the APIs in the test that were not part of the development spec? And this means that the spec cannot be considered golden, and then we can rely on the test spec to become your golden blueprint. So yes, we have that functionality, but it's not part of the free tool.
And I think there was a question asked earlier. It was answered as part of the Q&A, but maybe it's worth just repeating. So the question was, why are there two installation steps? First for the service, and then we have to install the sidecar.
Yeah, that's another great question. I mean, when we designed this particular tool, we wanted to make sure that it can perform at the same performance levels that your application is being used. So if you have a multi-node cluster with multiple instances of applications, different application services that you want to monitor, then it is important that the microsensor should be pretty smart as well as pretty performant. So we don't do a lot of processing on the micro sensor. So it's just looking at the network packets, trying to understand which one is an API and collects the meta information. But all this meta information is collected at the controller. So we need to have this controller, which is almost like the control plane, and the micro sensors, which is looking at the data plane, sort of an architecture. So we need both of them so that we can get all this API information together at one location and then summarize it there. A lot of our customer deployments have multiple instances running in different nodes in different clusters. So it allows us to be that kind of future proof for different architectures.
Great. Thanks, Ravi. I think that is all the questions. Actually, let me see. Oh, there's another question that just came in here. So in the sidecar for API Shark, does it introduce any performance latency or delays?
Yeah, another good question. So the sidecar is actually not an inline sniffer. It is just sniffing the network interface within the pod. So the first thing is we don't impact any of the application service that is running inside the pod, and we are not inline. And second thing is the sidecar, the CloudVector microsensor sidecar itself takes very little CPU and memory. In our benchmarking, it was as little as 4% of the CPU of the vCPU actually. So, and in terms of memory, it was less than like 30 MB, because we don't buffer. We do a one pass stream parsing and a lot of other optimizations as well. So it should not impact your application services because primarily it's not in line, and second, we have a very small footprint.
Great. Thanks, Ravi. So I think we have just a couple of minutes left. I did want to thank everybody for joining today. Again, as I mentioned at the top of this webinar, this is just our introduction into the API Shark tool. We will be having follow-up webinars where we dive deeper into some of the additional capabilities. So please keep an eye out in your email for the recording of this webinar and for future webinars. Ravi, do we have time for one quick question? It looks like we may just have a minute. There is a question here that says, can the console manage sidecar sniffers installed in a different Kubernetes cluster?
Yeah, that's another good question. So yes, it can install, it can manage. The only requirement is the sidecar in a different Kubernetes cluster should be reachable, or should have the network connectivity to the controller in another cluster. So as long as you can do that, we can achieve. Actually, when Dinesh showed you the microsensor setup, there was a location where you could define what's the name of your cluster, what's the domain, so that the sidecar can resolve to a controller which is on a different cluster.
Yes, great. That's a great point, Ravi. So I think I just took the default options, but if you were to customize that installation, that's where you would be prompted for the additional information that Ravi just referenced there. Okay, so with that, again, I'd like to thank everybody, and we will follow up with a recording of this webinar. And if you have any questions, please feel free to reach out to us. And for any support type related questions, please be sure to join our community. Thank you, and I hope to see you guys on a future webinar. Bye-bye.
Thank you.